So this video is going to be about how do we deal with lifting an object up in the air, what things we have to watch out for, what things we have to be careful of, what do we need to pay attention to. So here we have a helicopter just sitting on the ground. If we want to accelerate upwards, we'll first have to think about all the forces acting on the object. So when it's on the ground, we know that the object has its weight acting straight down, and also the support or normal force is going to be acting from the ground. This makes sure that the object doesn't go anywhere. It's not moving. So, but what if we want to get the object moving up to the air? What if we want to accelerate it upwards? So here we had to move it up in the air. That means we changed velocity. We had to accelerate, which means we needed a net force going in the upwards direction. We needed some F net going that way to generate that acceleration. So conceptually, how do we think about this? Well, we're going to think about it in terms of just keeping that helicopter even in the air, whether or not it's on the ground or not. We would first need to account for the weight. So if the weight's going to go down, that means we would need to exert a normal force going back up. If we want to accelerate upwards, well, we're going to need to figure out what F net is. So we need some kind of acceleration. We know that we might know the mass of the helicopter. We know F net equals ma. Since the helicopter is going to go upwards, that F net is going to also go in this direction. So F net is in the upwards direction. F normal force, which is just enough to counteract the weight of the object, is also in the upwards direction. So that means the applied force that we're going to generate from the rotors is going to be the sum of those two. So our lift force, or our applied force, is going to be the sum of the normal force and the net force. Because we're not only just having to compensate for the weight of the object, we're also going to generate an acceleration. And that Fn, that normal force, compensates for the weight. The F net is what generates the motion. So that means the applied force is going to have to be the sum of those two. So, for example, in this problem, we have a 2,500 kilogram helicopter at rest. It takes off with an acceleration of 2 meters per second squared. How much force do the propellers exert? Since our mass is 2,500 kilograms, we know our weight is 2,500 times 10 meters per second squared, or 25,000 newtons. So our force going down is going to be 25,000 newtons, which means just to make sure the helicopter doesn't fall, we also have to exert 25,000 newtons upwards. That would keep the helicopter perfectly stationary, but we're accelerating, so that means we have a net force. In this case, F net is 0 so far, but we know our F net is m times a, or 2,500 kilograms times 2 meters per second squared, or we have an F net of 5,000 newtons. So that means somehow or another, with this 25,000 newtons down and this 25,000 newtons up, we need to actually have a net force of 5,000 newtons upwards. To do that, that means the lift force is the sum of the normal force plus the net. So we're going to have to exert 30,000 newtons worth of force to actually lift this helicopter up in the air at an acceleration of 2 meters per second squared. Any less than 25,000 newtons, then the net force would have been going down. We have to exert more than 25,000 newtons to get that 5,000 newton net force in the upwards direction.